All right, class, so here we go. We're going to do test 2 review and get you all prepped and ready for this test, which is super easy. I think you are going to do fabulous on this test. All right, so I'm going to go to Insert File. Let me see if I can find that file readily. There we go. I sent you this file as well, so you do have access to it. It's in your Announcements tab, and so any work I do will likely be here. And let's begin with question 1. So this is going to be very similar to your typical homework assignment. And so the first thing they're asking you here is to determine what the null and alternative hypotheses are in this particular question. And so what they first bring up to mind here is, let me see why this is not working. Should let me, okay, maybe it's that. Now is it gonna write? Oh, so it's not gonna let me write. Nice. That's really helpful. All right, so I guess I'll have to minimize this and use this to write on. There we go. All right, so no worries. I hope you can see the questions just as well. And again, you have these on your screen as well. So the first thing that it's asking is, what are the null and alternative hypotheses based on the question? And so first things first is they're talking about the mean salary, which in this case, the HO is, you see how they say the word was is basically they're saying that the mean salary mu is equal to 8.16. And there's good reason to believe that the salary is less than last year. So this would be your alternative, which is going to be that mu is less than 8.16. So you look for that type of wording. All right, in the second part, it's asking, suppose that the union decides to reject the null hypothesis, what type of error would they be making, a type 1 or type 2? Remember that to answer part B, you go back to the type 1, type 2 error questions, and anytime they're talking about rejecting the null, we are deciding whether or not we're making a type 1 error or not. If we talk about failing to reject the null, then we're talking about a type 2. All right, in part C, it's basically saying, in this case, a type 1 error in this scenario would mean that we reject the null hypothesis. We would be rejecting the hypothesis that mu is, and then of course we're going to fill in this case 8.16, when in fact mu is equal to that. All right, so that's what they're asking you there. Remember, rejecting, and when it comes to type 1 error, we're rejecting a true null, and a type 2 error, we're failing to reject a false null. Okay, question number 2. In question 2, they're just asking us for the null and alternative hypothesis in this question. So it says the mean height of a certain kind of plant is 187. So we know that the null, which always contains equality, is that mu is equal to 187, because the null hypothesis always has equality built into it. In the question here, they're saying that suppose we want to carry out a hypothesis to see if the mean height when these plants are treated with a certain chemical differs. Anytime you see the word differs, we're using not equal to. So mu is not equal to 187. So the key there is the word differs. All right, looking at question number 3. In question number 3, again, this is very similar to your questions in the prior examples. So we have a furniture store. It says that it claims that a specialty ordered product will take on average 28 days to arrive. So we already know that the null hypothesis means that mu is equal to 28 days for the delivery time. The alternative never contains equality. By the way, you notice I use HA, but this could also be H1, either one, notation-wise. So in this one, they're saying that they also tell us the standard deviation. It says we suspect that the special orders are taking longer. So that means that they're saying that it's going to take longer or greater than 28 days for this to arrive. Now, because in this case they do give us a standard deviation, you notice it says in the second sentence, the standard deviation of the waiting times of the store are 6 days. That's the sigma. So in part B, we're going to answer because we know sigma. So I'm just going to write a little note here to remind you. We know sigma, meaning the population standard deviation. That's why it's a Z, not a T. Okay, in part C, we're calculating the value. Here's what we know. We know that mu is equal to 28. X bar is equal to 29. We have sigma equal to 6 days. We know the sample size is 150. And so what we're going to do here is we're going to either use the calculator, you can use a z-test, or we are going to use the formula where we have x bar minus mu over the standard deviation over the square root of n. So in our case, this becomes 29 minus 28. All of this divided by 6 divided by the square root of 150. When all the math is said and done, you should obtain a z-score of approximately 2.041. The critical value, given that this is at 10% and our hypothesis, because this is greater than is one-tailed, we're going to simply look up either using Excel or the calculator. We can use norm. So let's use Excel where we say norm S inverse, or you can use your Alex calculator. And we're going to put in 0.90 because it's greater than, and that should give us approximately 1.282. Okay, so, and then the last part of the question, in which case I would recommend you look up the z-score. So I'm going to actually go here for a second, and I'm going to use my TI-8384 just to be quick. And then I'll show you on Excel how to use this. And again, we've used or shown these examples in using various methods. So it's very important to me to find the p-value, because I think I've honed in on using the p-value. So if you're using the calculator, you're going to go to stat, you're going to go to test, you're going to go to z-test, and we're going to go to stats. Make sure you're in stats. If that is the case, then we know that our mu is 28. We know our sigma is 6 because they gave it to us. We know x bar is 29. N is 150, and because they said greater than, we're going to select this value here, and we're going to draw it. I like the draw feature. And there's your z value of 2.041, and a p-value of 0.02. Now, I remember I've shown you that if the p-value which in this case is 0.0204, is if P is less than the alpha, well, alpha is 0.10, we're going to reject the null. We also say that if the OV, the observed value that we calculated, that's this number here, is greater than the CV is this number here, the 1.282, and we can find that using a norm S inverse, we also reject the null. These go hand in hand. They don't contradict each other. They're always the same. So if that's the case, then as we read the question, it says, can we conclude that the mean waiting time on special order exceeds? So we are rejecting the null. So I'm going to say yes for part E. Yes, this does follow because our p-value is so small. Okay, question number 4. Very similar question. Here comes question number 4. So as we read the question, you notice that they're saying, in this case, that we're dealing with proportions. So if you read this carefully, they're saying that among students, the proportion that say they're interested in the district results has been. It's the same thing as saying is. So that means that the null hypothesis is that the proportion is equal to 0.7. It's a proportion because we're talking about 70%. Now it says a political science claims that the proportion P of the students say they're interested in the results is now less than, and you see that in the third sentence. So that would mean that your H1 or your HA is that proportion is less than 0.70. They do tell us that this is a z-score in part B, because we know in this case we can determine based on the sample size that is pretty large. We will say this is z. And in part C, we're going to use the test statistic. So according to this question, they are looking at a p-hat, and the p-hat is given to you as 155 out of 225 students. We're also using a 0.10 significance level. So this formula, which is p-hat minus p divided by the square root of pq over n, which will result in our final answer. So again, using a calculator, we're going to go to stat, we're going to go to test, we're going to go to one prop z-test, and so we're going to put 0.70 here, and this is 155 over 225, and they're saying that this is less than, so we're going to go for the middle, and we're going to go ahead and calculate. So based on this, we should have a negative 0.364 if you rounded, with a p-value of 0.358, which you can locate the p-value if you wish. And so if I did 155 over 225 minus 0.70, so what I would just do is just put a bracket or parentheses around this, divided by the square root of 0.70 times its complement, which is 0.30, divided by 225, which is the denominator in the fraction. And so this is how we obtain the value of negative 0.364 with a p-value, which is actually pretty large. It's 0.358. So I'm already thinking that this is going to be a no. Let me read the question carefully before I jump to conclusion. Can we support the political science's claim? No, because we are going to fail to reject a null. Remember, your alpha is 0.10. Your p-value is 0.358. P is greater than alpha. So we're going to fail to reject the null in this question. All right, next question, looking at number 5. And they're going to mix it up between very long questions and somewhat shorter questions. And so if I continue with number 5 here, all they're going to ask you with initially is to do the same thing, more of the same. And so in this question, as we address the steps in the question, let me go up a little bit. This is question 5. They're asking us for the null and the alternative. They're saying that the college records indicate that the mean IQ score for entering students in previous years is 113. So that immediately tells me that that is the null hypothesis where mu is equal to 113. And then they're saying in the subsequent sentences that it's actually increased. So the alternative hypothesis is that mu is greater than 113. The next question is this a z-score or a z-test or a t-test? This has to be a t-test because I don't have sigma. So this is a t-test. And our degrees of freedom for this t-test is 9. So that answers part B. So this is part A, this is part B. In part C, we're going to compute this computation or this formula. And in doing so, we're going to get a t-statistic of 2.635. How did we obtain that? So remember that in this case, if I'm using a t-test, move this over so I can get everything I need. So you have a sample mean. You have a sample size of 10, a sample mean of 123, a sample standard deviation, which is why we know for sure that we're going to use this calculation of 12. And we are given a mu, which is 113. And so the rule of thumb here doesn't really change. It's still 123, the x bar minus mu, 113. All of that divided by s of x, which is 12, divided by the square root of 10. All right, and so in doing so, we obtain 2.635 for the test statistics. So this is part C. In part D, they want us to find the critical value. So in the critical value, remember you use the t function with the little box where you're going to put in the degrees of freedom, and you want the area, which in our case, this is a one-tailed, so we're going to use 0.05, and our degree of freedom is 9, and then you should obtain, using your Alex calculator, a value of 8.33. So remember what I said, that doesn't change. If the OV is greater than the CV, we are going to reject the null. Based on that, since I'm rejecting the null, they're asking, can we conclude that the mean IQ score of this year's class is greater than previous? And answer choice E would be yes. We're going to fail. We're going to reject the null, so we're going to go and use the alternative, which is it's greater than. Okay, now in this question, we're looking at chi-square concepts. This is question number 6. And so one of the first things that you need to remember is that the expected frequency is easily found. In this case, we know this has to be 70 with no violations. If you read the question carefully, they give you a lot of information. So I'm going to write this over here. And I'm just going to sort of do a little box. So this is the observed frequency. This is the expected frequency. And this is the observed minus expected squared over expected. So we have no violations here, where this is 56. We have one violation, so I'm just going to draw a line like this. One violation. This is 13. Two violations. This is 19. We have 3 plus violations. I'm just going to, that's a T there, 3 plus. Think of it, 3 plus violations. We got a 12. And lastly here, a total. And this one is 100. So as we read the question, we'll get more information. So if you notice, in this case, it says AutoRex sells auto insurance and keeps close tabs on its customers' driving records, updating its rates according to the trends indicated by the records. AutoRex records indicate that in a typical year, 70% of the company's customers do not commit a violation. Notice that is 70%, so that goes here. We change it to a number. They give us a 10, they give us a 15, even though they do mention it in the question. And then as you continue reading, it says here 5% commit 3 or more moving violations. So that's 5 here. And so that's what we need there. Then it says this year's past driving records for random of 100 AutoRec customers are summarized in the first row of the numbers. They want us to then compute the chi values. So if we do observed minus expected squared.
Excuse me, Professor.
One second. Let's see here. Okay, so in this case, to obtain the last part, they're already giving you the formula. So basically all you have to do is say, well, then I have the observed, which is 56, minus 70, all of that squared, divided by 70. Okay, so be careful with the order of operations. That's the only thing I can see that could be an issue. And so I'm going to begin with, let's just use this calculator so you can actually see the calculation. So we're going to go to, I'm going to go to mode clear here. And I'm going to do parentheses. And let's do 56 minus 70, close parentheses. Raise that to the second power. And we're going to divide that by 70. We're apparently having typing issues. 56 minus 70, raised to the second power. And I'm going to divide that by 70. Notice that I get 2.8. And so this answer here should be 2.8. And they are giving you this information. Okay, let me go back to the question. See if I can minimize that. They're giving you this value here. This is given. This is given. All right. And the other percentage that we're missing here, let's see here. We have the 70, we have the 10. Yeah, the 15, I said that was 5, so that's good. They did give us this at 0.9. They did give us this as 1.067. And so for this one, we would say then, okay, so this is going to be so we're going to go with 12 minus 5 squared. And all of that divided by 5. Okay, so if we do the math here, we should obtain a value of 9.8. Watch your order of operations. All right, then they ask us what kind of test this is in part. What is a test statistic? This is number 1. And so in 1, this is a chi-square. All right, and in part 2, they ask us to calculate the actual value of the test statistic, which if we add up all of these values down here, we add all these up, you should end up with 14.57. Now the critical value, we're going to also use the Alex calculator. You guys can do that for number 3, which in this case, given that we have an alpha of 0.10, and if you remember, the degrees of freedom is row minus 1 times column minus 1. So in this case, rows, you have 2, so 2 minus 1 is 1. And columns, we have 4. We don't count the totals, so we're going to use 1 times 3. So in this case, our degree of freedom should be 3. When you use the calculator, this should result in 6.25 for your CV. And so remember that in this case, our null and alternative hypothesis basically tell us whether or not there's a difference. And so in this case, the OV is greater than the CV. So if the OV is greater than the CV, we are going to reject the null. If I reject the null, then I'm saying yes. There is, can we reject that there is no difference? So in actually this case, you would say yes, there is no, that we can say that. Okay, question number 7, same thing. I'm not going to do this one, it's the same process. They're just simply going to ask you the same questions. You're going to need to calculate the missing expected frequency. Actually, I will do this one because you may not know how to do that. So to find this number, for example, so you have crush wins, crush lost, and total. So I'm just going to do it like this to help you see the big picture. All right, so we've got 42 in the first. This is 13. As you can see, the total is the addition of these two to get 55. This is 26. This is 19. The addition of these is 45, of which those add up to be 100. This gives you 68 and 32. This is picked, crush to win. This is picked, crush to lose. And again, this is the total. So they're asking you to solve for this expected value here. And so to solve for that expected value, you're going to multiply row total times column total divided by grand total. In other words, the 100. Okay, you repeat that process here. So this one will be row total times column total divided by grand total. And for this one here, this would be row total times column total divided by grand total. And the same thing over here, row total times column total divided by grand total. And so the values that you're missing are for this first box. I'm just gonna sort of do this. Here's the dot. So this is 37.40. This one here should result in 14.40. And this one over here should result in 17.60. They didn't ask you for that other value, so don't worry. All right, continuing with this question. So in this one, they're asking you about the various types of relationships that are present here. So which data set indicates a perfect linear relationship? MN would be the selection for that one. For B, it says for which data set has a positive but not perfect linear relationship, I'm going to select WT for that one. On C, it says which has the strongest negative relationship between the variables. I would select UV because it's technically the only negative you have. And the last question says, in which data set is there evidence of a strong nonlinear? In this case, none, because there are no nonlinear. For it to be nonlinear, typically it's a parabola. It'll look like this, or it'll go the opposite way. So you can't lose in that case. All right. In question number 9, they're simply asking you to draw the line that would fit. In this case, you would just simply draw a line that would fall right in between the dots, and you would have access to that. They're just asking you to sketch it. Okay, and then this last question here. So I'm looking at part A. It's saying if you look at the behavior, it's going positive. So it says fill in the blank for the data current stock prices that are greater than the average, meaning they're sitting above this line. They're paired with values that are also greater than those of the mean. Okay, so that's that interpretation. According to the regression equation, for an increase of $1 in earnings per share, there is an increase of 0.043, and you know it's an increase because it's a plus for the slope. Number 3, it says from the regression equation, what is the predicted current stock price in dollars of earnings per share that is $30.88. And here you're just going to plug it in, and you should get basically using this equation. So you have predicted y is equal to negative 0.141 plus 0.043. And then we're going to put in the 30.88 here. Now just do some math. Remember, you're going to multiply that and then add the negative. And you should get, I'm getting 1.19 on my calculator. Now the difference between C and D is that D is observed. And what was the observed current stock price in dollars when the earnings per share was 30.88? So I'm going to go to the chart very clearly, and I'm looking at X, where X is 30.88, and I'm going to select, in this case, the current stock price. The current stock price is 1.32. So I'm looking at how it matches to the Y column. Okay, in the next question, still in regression, This is actually very easy for most of you, so I hope this question was somewhat easy. This is question number 11. All right. In question number 11, what we're going to do is we take the numbers, we throw them into Excel. You can see that the least square regression line has a slope of approximately negative 0.47. They want to know what is the y-intercept of the least squares regression line. And then they also want to know what the correlation is. What I would suggest, like I said, in this case is let's grab an Excel sheet, and I'll go ahead and I'll do this step by step. Now you guys have a lot more freedom because in your case, you can just import your values, which makes your life a lot easier. In my case, I'm going to have to copy this over. So what I'm going to do is I'm going to pause the video for a moment and throw in the number. Okay, so assuming I didn't make any entry mistakes, which you guys can pause the video and see if I did. What you're going to do here is to find the y-intercept to answer part 1. You simply go equals intercept. Double click on it. It's going to ask you for the y terms first. Put a comma. And then it's going to ask you for the known x's. Enter. That's the y-intercept for this particular equation. They're asking you for the correlation coefficient. So all you have to do is say equal correl. Double click on correl. Select array 1, comma. Select array 2 and hit enter. And so in this answer, your answer should be negative 0.81296. If they happen to ask you to discuss what that means, you're going to say that there is a negative but strong association between the two variables. Because it is negative 0.81, which is pretty strong. All right, question number 12, you should already be handy with. I'm not going to go over 12. In question 13, we're talking about a t-test. You can simply put this into list 1, list 2, and find the sample mean, find the sample standard deviation, and you can easily obtain answers for this one. So let's take a quick peek at number 13. You can also put the data in the calculator and solve for it that way. That's also another option. So the first thing that I'm going to focus on this question is, after reading it, they want to compare annual incomes between childcare workers in New York and Rhode Island. So they do give you the 2 data points. They give you the population standard deviation, so you know it's a z-test. In part A, looking at the question, the first thing that they're asking us in this case is let's see, where does it say that? At the 10% level, I'm reading just below the box and about the second line. At the 10% level of significance, is there sufficient evidence to support the claim that the mean annual income mu1 of childcare workers in New York is greater than that of mu2? So when you set up the null hypothesis, the HO, you would use mu1 minus mu2 is equal to 0 as your null. Your alternative, based on the way the definition is written, is that mu1 is minus mu2 is greater than 0. Again, they gave you the population standard deviation just below the box. You see it says, so it would be a z. In part C, if we're comparing those two, we should end up with a t-value of z-value of 2.437. Since it's one-tailed, our answer choice for D should be 1.282 at the 10% significance level. That does not change. And so since our OV is greater than the CV, we are going to reject the null, and we are going to say that yes, we can support the claim. Yes, we can support the claim that the mean annual income of child care workers in New York is greater than that of individuals in Rhode Island. Again, you can use your calculator or you can use your Excel to do that. Okay, in the next question, I'm going to take a moment to really focus on this. So we're looking at number, I think this is what, 15? No, 14. Okay, so we want to know the estimate of the common population variance. And so remember, I showed you this in the ANOVA. This is number 15 is all about ANOVA. And I guess I can replicate this and share that with you. Let me do that. Let me just copy this into Excel. One second, I'm going to pause the video. Okay, so as I went ahead and copied this and not waste your time watching me copy down the information. So the first thing I want you to do is, let me just align this a little bit. Okay, wonderful. To answer the first question, it says give an estimate of this common population variance based on of the sample means given the following information. So what I would do is I would start with equals of R dot S. And this is the sample size, by the way. This is the sample. Let me escape from here. Let me just click this. So sample size, which is important. This is the sample mean. And this is the sample variance. Okay. So going back to this, we're going to say equals var. We're going to use var.s because we have samples. And you get initially 19.26, and now we're going to take that and multiply that number times 78. And your answer should be 1,502.28. That answers part A in the question. To answer part B, and pay attention to the language here, because notice that this almost sounds like the same gibberish, but there's a slight difference here in this question. It says given an estimate of this common population variance by pooling, the sample variance is given. So in this case, you're going to take the sample variance and you're going to say equals average. And we're going to take the average of these sample variances. And you get approximately 410.05 or 410.1 if they ask you to round. All right. Once again, I'm going to pause the video so I can copy this chart over and be able to answer this for you here. So I'm going to... Okay, as I continue here, I've gone ahead and copied this. I want you to pay attention to this question. You see in the question very clearly, right about or just above the box, they give you the F-test statistic to be 4.21. Keep that in mind. And they're asking us for the numerator and the denominator of the sample. Now, what I want you to remember is that the numerator, or the variation between samples, so if I'm looking at the fraction, this is going to be basically k minus 1, where k is the number of groups So I have 4 groups, so this is 4 minus 1. So this denominator value is, or numerator value is 3. For the denominator, remember that the definition was n minus k, so I need to know the sample size here. So if I do auto sum, or I do equals this number plus this number plus this number plus this number, I get 374. So 374 minus 4, hence k is 4, gives you an answer of 370. And so they gave us an F statistic. We know that this is equal to 4.21. All right, and so the question here then is, can we conclude using a 0.05 significance level that at least one of the mean daily sales is significantly different from that of others? Remember that the HO for this, in essence, is that mu1 is equal to mu2 is equal to mu3 is equal to mu4 in terms of the groups, and the alternative is that they're totally different, or at least one is different. So you would say mu1 is not equivalent to mu2, not equal to mu3, and not equal to mu4. Okay, and so if you recall, I did suggest to you to use a function in here. I think it was it f dot dist? Let me see. Yeah, so we would use the 4.21 comma the 3 for our numerator, comma, and the 370 for our denominator, and we would need a comma, and then cumulative. Double click on it and hit enter, and you get 0.99. So remember, it's always equal to 1 minus that, because it's always a right tail distribution, and that's 0.00603. So that's our p-value. This is the p-value. Remember, alpha is 0.05, so p is less than alpha, we will reject this null. And so yes, we can conclude that there is a difference, and that's number 15. Okay, number let me close that down. Number 16, you're going to basically take the 262.26, so 262.26, you're going to divide it by 94.98, and you're going to get 2.76. All right, and then everything else is given to you. How many countries are studied? Obviously, for part B, this answer would be 3. And you just simply look at the treatments between groups and add 1 to that. For the ANOVA test, it is assumed that the population variances of flight delay times are equal for each country studied. What is the unbiased estimate? So the unbiased estimate in this case would be part C, which is 94.98. What is the p-value? So we would use our statistic and the same function I just did. So you can equals 4 f dot dist. Look at your degrees of freedom. So you would do 2 comma 666, which is what you have. Our number is hideous, I'm sorry. And the number they gave you, 2.76, comma, and then cumulative. And you should get a p-value of 0.064. Actually, you have to do 1 minus the complement of that. So let me show you on Excel. Okay, so using Excel, we will go, again, equals f dot dist. We would use our number, which was, what did I say it was? 2.76, comma, and again, we're going to use 2 degrees of freedom, comma, the 666 comma and then cumulative. And then that gives us that number, 0.93. And remember, it's always right tail, so 1 minus that number, which will give us 0.064. And that's what we're looking for. And we have to go back to the question because we need the alpha value. 0.10 significance. So our p-value is 0.064. And that is definitely less than 0.10. So we're going to reject the null. There definitely is a difference. So yes would be the answer for that one. Okay, for number 17, you guys are used to that one. I'm not going to do that one. The differences, we've done millions of those. You should be good with that. And same thing goes for the last one. I think you guys are fine for this. Overall, that's all I'm going to go over for the test. If you have any questions, you can always reach out to me.